फिर बात करेंगे मोशन ऑफ सेंटर ऑफ मास के बारे में। We know that position vector are of a system of n particles is given by equation vector r is equal to 1 upon m sigma I is equal to 1 to I is equal to n mi और वेक्टर आर आई और एम आर वेक्टर सिग्मा आई इक्वल टू 1 टू आई इक्वल टू एन एम आई वेक्टर आर आई। यहाँ से हो जाएगा एम वेक्टर आर इक्वल टू m1 r1 वेक्टर प्लस m2 वेक्टर r2 प्लस डैश प्लस mn वेक्टर rn प्लस डॉट। इसको देते हैं इक्वेशन फर्स्ट। assuming that masses m1, m2, mn and total mass m do not change with time and differentiating both sides of equation first with respect to time we get m dr vector dt m1 dr1 vector upon dt plus m2 dr vector upon dt plus dash mn dr vector upon n upon dt plus dot. was the equation second. Now dr1 vector upon dt is equal to vector v1 and the velocity of first particle velocity of first particle dr2 vector upon dt is equal to vector v2 is equal to velocity of second particle and so on. dr vector upon dt is equal to vector v velocity of center of mass of the system particle of the system of particles. Therefore m vector v is equal to m1 v1 vector m2 vector v2 plus plus mn vector vn plus equation third differentiating both sides of equation 3 again with respect to time we get m dv vector upon dt is equal to m1 d1 vector upon dt plus m2 dv2 vector upon dt plus mn dv vector n upon dt plus ऐसे हो जाएगा m a vector is equal to m1 a1 plus m2 vector a2 plus mn vector an . This was equation 4. Here vector a1 is equal to d vector upon dt acceleration of first particle vector a2 is equal to dv2 vector upon dt acceleration of second particle and so on. Vector a is equal to dv vector upon dt is equal to acceleration of the center of mass of the system of particle of the system of particles. According to Newton's second law, Newton's second law, m1 vector a1 is equal to vector f1 vector sum of all the forces acting on the first particle. M2 vector E2 is equal to vector F2 vector sum of all the forces on the second particle and so on. Therefore, equation 4 is or equation 4 can be written as m a vector is equal to vector f1 plus vector f2 plus dot 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 vector fn plus fn. Therefore, total mass of a system of particles multiplied by acceleration of its center of mass is equal to vector sum of all the forces acting on the system of particles. Among these forces, there will be external forces exerted by agencies outside the system and also internal forces exerted by particles of the system on another. We know from Newton's third law the internal forces exist in equal and opposite pairs. Therefore, their distribution is zero. Only external forces contribute to equation 5, which there we rewritten as equation 5 can be written as m vector a is equal to vector f external, here vector f external is the sum of all external forces, all external forces acting on the particles of the system. From equation 6 shows that center of mass of a system of particles moves as if the center of mass of the system were concentrated at the center of mass and all the external forces were applied at that point. Hence, we conclude that whatever the system of particles and whatever the motion of its individual particles, the center of mass of the system moves according to equation 6. This is how translation motion of a rigid body is separated even when it is rotating as well. The same is true for a system of particles with all kinds of internal motion.